Another technique for evaluating limits is to use common denominators. For part A, we have the limit as h goes to 0 of 1 over 5 plus h minus 1/5 all over h. First, quickly note that if we just plug in 0 for h, we'd get 0 over 0, which is an indeterminate form, which basically means we better do a little bit more work. So in this case, we can use common denominators to get rid of that h in the denominator, and that's always our goal in these kinds of examples. This example is actually what's known as the derivative, which we'll get to. But let's see if we can make this work out. So let's do a common denominator up here in the top. We have 5 plus h and 5. So we'll do an LCD, least common denominator, how about that, of 5 times 5 plus h. Okay, so what that means is we need to multiply 1 over 5 plus h by 5 over 5. Okay, and then 1/5 by 5 plus h over 5 plus h. Okay, so what does that give us? We now have the limit as h goes to 0. Yes, you need to write that every time. I know it's somewhat cumbersome. 5 over, well, we'll just have a single denominator here. So we have 5 times 5 plus h. And then 5 times 1 is 5 minus parentheses 5 plus h. And now this is all over h. But when you have a fraction, let's see, when you have a over b all over c, you can just bump that top fraction down a layer. So you have a over bc. This can be seen by writing c as c over 1 and multiplying by the reciprocal if you really want to see how it works. So I'm going to bump this down a layer. That gives us, we can just put the h up here next to the 5 times 5 plus h and get rid of everything else. Okay. Well, now we have some nice cancellation there in the numerator, so that gives us the limit as h goes to 0 of 5 minus 5 is 0, leaving us with simply minus h over, I'll write this denominator as 5h times 5 plus h, and there we get that cancellation we've been looking for. Okay, so looking good. Limit as h goes to 0 of negative 1 over 5 times 5 plus h. And now we can simply plug in 0 for h, because this is a rational function after all. It's defined at h equals 0. This last result we have giving us negative 1 over 25. Okay, moving on to part B, we have the limit as w goes to 1 of the quantity 1 over w squared minus w minus 1 over w minus 1. Now if we just dive right in and substitute 1 for w, we'd get infinity minus infinity, or some version of that, which is an indeterminate form. Infinity minus infinity is not 0, it turns out. So we need to do a little bit more work here. And one of our best tools for this kind of example is to mess with the denominators and see if we can get something to work out. So let's see if we can get a common denominator here. Well, this first term factors into w times w minus 1. So then from those two terms, we can see we have a nice LCD, least common denominator, of w times w minus 1. We're all set up in this first term, but we need to multiply the second term by w over w to get that LCD. What this leaves us with then is the limit as w goes to 1 of, okay, now this whole thing's going to be over w times w minus 1, and then we have 1 minus w up top. Well, we almost have some cancellation here. Let's try this. Let's try factoring out. So I'm going to write limit as w goes to 1. How about we factor out a negative right from the top there? That changes the sign of everything left behind, which would give us w minus 1. Now, in the denominator, we still have w times w minus 1, and there's the cancellation we've been looking for. So we have the limit as w goes to 1 of negative 1 over w, which is negative 1. All right, so finding a common denominator can be a wonderful tool when you're trying to evaluate limits where the denominators don't quite line up just right.